we want to now think about what is marginal revenue. Of course, that's a big part of the firm behavior question because the firm is going to weigh the costs and benefits of production, and the cost is marginal cost, the benefit is marginal revenue. So how do we calculate marginal revenue when we have a firm with market power? All right, there's a real simple rule that you can use to find marginal revenue when you have this linear demand curve, all right? And in this class, we'll always have linear demand curves. So here we have P equals A minus BQ. Normally those are numbers, but I've stuck in some letters there to stand in for the slope and the intercept of demand. Marginal revenue would be equal to A minus 2BQ, okay? So this is what you want to remember here. And actually, I think it's easier rather than remembering all the A's and B's. The best thing to do is just to remember that to get marginal revenue, you're just going to multiply the slope of demand by 2. So you take your demand equation, you multiply the number next to the Q by 2. Then you've got your marginal revenue equation. Why is that? That seems really arbitrary. Why is that our marginal revenue equation? Well, the answer is math. You don't have to pay attention to this, plug your ears, fast forward the video, that's fine. But some of you will find this a little bit satisfying to see why is this arbitrary rule true. So I'm going to show you. What we want to remember is that to get marginal revenue, what we're doing is we're taking the change in total revenue divided by the change in quantity. The first thing we need to recognize is that this means this is the derivative of the total revenue function with respect to quantity. We can write out our total revenue function, that's price times quantity. And when we have a fixed price, like in perfect competition, then we can just take the derivative. And the derivative of total revenue would just be equal to price. That's why in perfect competition, marginal revenue is equal to price. But in this case, price is a function of quantity. We have a downward sloping demand curve, meaning that price you set determines how much you will sell. So our total revenue function, we need to plug in the relationship between price and quantity, which is given by the demand curve. And we can simplify that. That's AQ minus BQ squared. And now when I go to calculate marginal revenue, I take the derivative of my total revenue function with respect to quantity, I get A minus 2BQ. Right? So it is always true that linear demand will have this marginal revenue function. And if you've plugged your ears, if you're fast forwarding, come back now. All right, we're going to look at the graph. Here with this graph, we have our demand equation and our marginal revenue equation, and it's always going to look exactly like this. So your demand equation starts at some intercept, that's this number in your demand equation, A, and then it comes down to the x-axis, just A over B. Your marginal revenue equation has the same intercept. It's going to start at the same point as the demand curve, and then it's going to come down and intersect the x-axis at half of demand's intercept, right? Because it's twice as steep, it comes down twice as fast, so the intercept will be half of the intercept for the demand curve. Marginal revenue will always look like that. We know how to calculate marginal revenue. The next step is to apply that to a monopoly problem, and we'll do that in the next video. Stay tuned.